Hello everyone. All right, so today we're going to do week 9 of review, and it's all about radicals. All right, so the first question is to find the square root of 100, right? All right, so the square root of 100, but here we are looking for the root, okay? And now, even though I didn't make the difference between the square root and finding the root, the square root of 100, which is a principal square root, represent the positive numbers. So here it says find the root, but they're also saying just represent everything as a positive number, which makes sense. It will be square root of 100. Okay? So in this case, let me get to this here. Yeah, so in this case, it would be, because 10 times 10 is 100, so 10, positive 10 is the root. Okay? So that's it. All right, so let's do that with, variables, right? So here, because the negative here is in front of the square root, we're actually representing the negative root of x to the power 48. Okay, so the negative remains, and then the sixth root, right? So the index here is 6. And then here we have x to the power 48. All right, so by this time you should know, based on your reading, that you can simplify this as x to the power of 48 over 6, right? So the rule here is simple. If you have the square root of x to the power of 2, square root of x to the power of 2, right? You can rewrite this as a rational exponent, meaning that you have x, the base, then the 2 here, or the exponents, will be the 2 of the rational exponents. It will be the numerator. And then the index here, since there's no index here, you assume that it is 2, right? So the index, if you don't see anything, you assume that it is 2. And so here is going to be 2 over 2. And we know that 2 over 2 is 1. X to the power of 1 is just x. So that's the rule. Okay? So let's do another one, maybe the fourth root of x to the power of 8. Then you can rewrite this as x to the power of 8 over 4, which gives you x to the power of 2. Okay? So whatever you have here as an exponent and here as an index, you can rewrite it as a rational exponent and get your answer. So basically this is what we have here. So we have negative x, and then we have 48 divided by 6 is 8. So negative x to the power of 8 is your answer. Okay, so this is like a shortcut. All right, so here we want to find, so we have kind of the same thing, but here we have a positive rational root. Rational exponent, I'm sorry. And so, let's go through it. So here, the 1/4, so if you look at the rational exponents, this is really, if I were to write this, it will be the fourth root, so that's the index here, of 1 over 625. And the 1 represents the exponents of 1 over 625, which is just basically, when you write it, is the fourth root of 1 over 625. Okay? So what is the fourth root of 1? So you can break it down if you want to. The fourth root of 1, and what is the fourth root of 625? Right? The fourth root of 1 times 1 times 1 times 1 is 1. So it's 1. And then here it will be 5, because 5 times 5 times 5, 4 times will be 625. So the fourth root of 625 is 5. Okay? Now, when you have a negative exponent, so we've seen that when we did exponents, you have negative exponents, then you can, to make it positive, you always want to make it positive, then you write this as the reciprocal, right? You want to put it as a reciprocal first. which is 625 over 1, which is the same thing as 625, right? So 625. And then we're going to put the rational exponent as positive now. So these two here are equivalent, right? So they are equivalent. They are the same. Okay? It's just easier for me to compute this. So now now we saw from the previous one, when we have a positive rational exponent, I can rewrite it as the fourth root of 625 to the power of 1, right? But I don't have to put the 1. And the fourth root of 625, we saw it earlier, is just 5. So your answer is just 5, right? And it becomes 5, not 1 over 5 because of the negative exponent. You had to put it as a reciprocal. Okay. All right, so more rules. All right, so we've seen the rules for exponents. So it's kind of the same thing, but now we have rational exponents, right? So how do I break this down? So this is the power rule. So basically, I have to kind of distribute the power. So here I have 27 to the power of 1, because that's what it is, 27 to the power of 1 times 2/3, right? I'll do the same thing here, x to the power of 3 times 2/3 over 216 to the power of 1 times 2/3. Okay? And then here I just simplify, right? All right, so what is this? So if I do 27 to the power of 2/3, it's really 27 to the power of 2/3. 1 times 2/3, right? And then I convert that into a radical, so it's going to be the cubic root of 27. But now there's different ways that you can write it. And then let's do it the way I've done it before. I put 2 here, which means that I'm going to have to evaluate 27 to the power of 2, which is going to give me a big number. I don't know what it is, but if I put 27 to the power of 2, that gives me 729, right? And cubic root of 729, which is fine. You may recognize 729 as being a perfect cube, which is fine. Okay? And then you realize that, 9 times 9 times 9 gives me, 9 to the power of 3. Yeah. So 9 is your answer. But now let's look at another way. Also note that 27 is also a perfect cube, right? 3 times 3 times 3. So I can rewrite this as the cubic root of 27, right? I know that's going to give me 3. And then I have the luxury of putting the 2 here, the exponent, on the outside here. And so really, here I have an easier time to find this is equal to, because I have the cubic root of 27, which is 3, and then 3 is raised to the power of 2, and then you have 9. Instead of just trying to figure out the cubic root of 729, you may not know that this is a perfect cube, and then you just spend more time. This is more familiar. Cubic 27, cubic root of 27 is 3. 3 squared is 9. Those are smaller numbers that you can deal with. Okay? All right. So I'm not done because I only did 1 here. I wanted to move on. So I have 9. Then here I have 3 times 2/3. The 3 cancel out. So I'm just left with x squared. So x squared. And then this is 216. 1 times 2/3. So same thing here. We have 216, right? The cubic root of 216 to the power of 2. I don't want to do that because 216 to the power of 2 is going to give me a very large number that I'm pretty sure I'm not going to recognize if there is a perfect cube within that. So I want to put cubic root of 216, and I know that it's going to be 6 times 6 times 6, right? And then raise it to the power of 2, right? So this is 6, and then I'm going to square it, and that's going to be equal to 36, okay? So it's going to be 9x squared over 36, okay? So I kind of broke it down into 3 parts, right? So you have this first part right here, right? Well, you can choose either one, so those are the same, right? And then you had this part where I just kind of simplify this, and then the third part is the denominator. Okay. All right. Let's move on. All right. So here we have kind of a complex one. So let me. All right. So it's kind of the same thing here, right? It's just the power rule with a combination of product rule and so on. So let's see what we have. Here I have the kind of luxury of looking at whatever is inside the parentheses and see what I can simplify first, because it seems like it's very confusing. And then here I kind of recognize that I have x to the power of 1/4 and also have x to the power of 1/4. Beautiful. They're the same on top and at the bottom, so I can kind of cancel them out, and it's just 1, right? So go to the next step. I get 4 squared. Oops. Y to the power of 7 over to the power of 1/2, right? It's a positive 1/2 as a exponent, so I can multiply the exponents by 1/2. So I have 4 squared times 1/2, and then I have y to the power of 7 times 1/2. Okay, when I simplify, the 2 over 2 cancel out. I have 4 to the power of 1, that's 4. And then here I have y to the power of 7 over 2. Okay, cannot simplify that because otherwise it's a decimal. And then I can represent this as a radical if I want to. That's going to be 4. And then the 2 is my index, so it's just square root. And then y to the power of 7 inside the radical. And that's my answer. Okay. All right. Let's move on. So here I have, so here I'm just going to distribute this stuff here inside the parentheses. And so I'm going to multiply this with this, then this with this, right? So let's write it out. 2x to the power of negative 1/4 times 2x to the power of 3. And then minus 2x to the power of negative 1/4 times x to the power of 1/4. Okay? So here for the product rule, we're going to use the product rule here because we have a 2 and a 2, and then we have a x and an x with exponents. So we know what to do here, right? When you multiply 2 exponents, you add the exponents. You add the exponents. So you have 2 times 2, 4. And then here we have x to the power of negative 1/4 plus 3. That's the way we're going to deal with this. Then here we have 2 times 1, right? We assume this is 1. So it's just 2. And then here we have x to the power of negative 1/4, since multiply, plus 1 over 4, right? So plus this here. All right, so all I have to do here is to simplify this and simplify this and see what I get. Okay, so the negative 1/4 plus 3, we should know how to do this. That's the equivalent of negative 1/4 plus 12 over 4, right? I want the same denominator, and then I want representation as a fraction for 3, 12 over 4. Okay, beautiful. That's going to give me negative 1/4 plus 12 over 4. That's 11 over 4. So this here is going to become 11 over 4. So I have 4x to the power of 11 over 4 minus 2 times. And what is that here? Negative 1/4 plus 1/4 is equal to 0. So here, that's going to become x to the power of 0. We know that x to the power of 0 is equal to 1. So it's going to be 2 times 1. And here my next step will be 4. I'm going to turn this into a radical. So it's going to be the 4th root of x to the power of 11 minus 2 times 1, which is 2. Right? X to the power of 0 is equal to 1. That's what it means.
Put your glasses on.
Oops, sorry. I got distracted. Somebody sent me a video of my kids. Anyway, dancing, yeah. Anyway, alright, so get distracted for like a good 30 seconds, 45 seconds. Alright, alright, so that's it. That's the answer. Let's move on. Alright, so here we want to find the root and we want to use the absolute value bars when necessary. Alright, so I like the way they use finding the root. Yeah, you're finding the root, yeah. Alright, so why is it so important here? Use absolute value bars. Alright, so if we say that we're finding the root versus finding the radical, right? Or the principal radical. What it means is that, like for example, if I have the square root of x squared, obviously x is an unknown, correct? It's unknown. Right? And the unknown means that it could either be positive or negative, right? Because x represent any values, right? X represent, it's a variable, so it represent anything. It could be positive or negative. Now, there is a rule for square roots, right? Square root represent only positive numbers, right? If I have negative square root, then it represents the negative side. But inside the radical, I should only have positive numbers because, so for example, square root of 4, right? Is either 2 times 2, right? Or if I have, or negative 2 times negative 2 if I'm looking for the roots, right? But if it's just square root of 4, then it's just 2 times 2, right? So it's either way. Well, here I'm finding the root. So here it's 2 times 2 or negative 2 times 2, negative 2. But there is no combination because when you're looking for the square root, you're looking at two values. When you multiply them, will be equal to positive 4. But there is nothing that's going to give me square root of negative 4, right? Right? So negative 2 times negative 2 is not negative 4, and 2 times 2 is never negative 4. So here, you say that this is not a real number, Okay? And so in this case here, that will not exist. So even though now I have x and it represents positive and negative numbers, but I have to make sure that the end, this expression here, let me use this expression, x squared, which is always going to be positive, when I find what x is, x should be representative of a positive number. So what do I mean by that? That my answer here should be x, and let's not forget x is positive or negative, but I need the representation of a positive number because this is square root of x. Okay, so therefore, I have to use absolute value to make sure that this is positive. Okay, because x could either be what? Positive x or negative x. Right, so let me put that here. It could be positive x or negative x. Okay, hard concept. So let me recap. The square root of a number represents the principal square root, right? And therefore, it produces like really 2 times 2. Okay? And let's forget about the negative 2 times negative 2. It represents 2 times 2. Okay? So that's because of the principal square root. Now, because it represents the positive side of alright, so because x is unknown and represent positive numbers and negative numbers, then when I find my answer, which is just x, I need to make it representative of positive x. Okay? And the only way I can turn negative x into, well, a negative value into a positive is to apply, the absolute value. Okay? I mean, let that marinate into your head a couple of times and you understand. Okay? And that's also based on the index. It only works when applies when your index is even. Okay? In the next problem, for example, if my index is odd, then the value under the radical could be positive or negative. One or the other. It doesn't really matter. Okay? So this is really negative 4 to the power of 5 over 5, right? And this is just negative 4. That's it. I don't have to put an absolute value or anything like that because the answer could be equal to negative 4. But if I have something like, the sixth root of negative 6, let me put the negative 5 to the power of 6, right? Then I have negative 5 to the power of 6 over 6, which is negative 5. I cannot have negative 5 as my answer because my index is even. So I need to represent this as absolute value of negative 5. That must be done. Okay? Because that value here has always, it has to be representative of a positive number, not a negative one. Okay? So very important. All right, so moving on. Let's do these two here. And, let's do the rationalize the denominator. And I'm just going to do these two. And then I'm going to move on to, some harder ones. Right? So here we have rationalize the denominator, meaning that this is kind of the same thing as square root of 121. Ooh, sorry. square root of 121 over square root of x, right? And when you rationalize the denominator, that means that you don't want to have a square root expression as in your denominator, right? And to get rid of it, I need to kind of rationalize. Rationalizing meaning that in order for me to get rid of that square root of x, I can multiply this by itself, because it's going to cancel out. So, for example, if I multiply the bottom by square root of x, square root of x times square root of x is square root of x squared. And we know that square root of x squared is positive x. All right, here, assume that all variables represent positive numbers. That's why I don't have to put the absolute value, because I know that x is always positive. So here, just to make sure that you understand that the reason why, because the previous problem, we're not assuming that all variables are positive. We're assuming that x is either positive or negative. Here, from the get-go, we're assuming that it is just positive. All right, so that's just x here. So the square root is gone, and I've taken care of my problem. But obviously, I want the expression to be equivalent. So if I multiply the bottom by the square root of x by itself, then I need to multiply by the top by square root of x, because square root of x over square root of x is 1, which makes it equivalent. Okay? And that's it. Okay, so let's, square root of 121 is 11, and then you have square root of x, 11 times square root of x, so it's going to stay the same, over square root of x times square root of x. We just did that. That's just x. And so this is the answer, or the equivalent of this. Okay? That's when you have just one term, right? You just equate it to itself. And for this problem, especially for the square root, you just multiply by itself, and then you will get this type of answer. Now if you have two terms, then you need to multiply by its conjugate. And the conjugate of this denominator is just what you have on top here. It doesn't always happen. It just happened that the numerator is the conjugate of this. Conjugate means that something like this, a plus b and a minus b. You basically have the same terms, but one of the binomial is an addition, and then the other one is a subtraction or a difference, right? A sum and then a difference. So that's why I should have put a sum, and then the other one is a difference. And those are called conjugates. That's it. Yeah, conjugates. Okay? So that's it. Sum, difference, these two are conjugates. And basically, that's what we have here. So I need to, in order for me to get rid of the square root here, because the denominator has a square root term, I need to, and the other one is not, even if it was a square root of 7, I will still need to multiply by its conjugates, because I have two terms. So here I'm going to multiply the bottom by square root of x minus 7, right? And then the top by square root of x minus 7 as well. And put everything in parentheses. Okay? And you're going to see that the square root at the bottom is going to cancel out when you multiply. Alright, so let's multiply the top here. The top doesn't, it could have square roots, it doesn't matter. So square root of x times square root of x is square root of x squared, which is just x. Then you have the outer, so you use the full method, negative 7 square root of x. And then the inner, negative 7 square root of x again. And then the last term, negative 7 times negative 7 is positive 49. Okay? We'll simplify in our next step. The bottom one, kind of the same thing, but now we have to take care of, we have a plus and a minus. So square root of x times square root of x is square root of x squared, which is just x. Then you have square root of x times negative 7. That's negative 7 square root of x. And then here, the inner is positive 7 square root of x. And then positive 7 times negative 7 is negative 49. Okay? Different. Now, let's simplify. So here, you can see we have negative 7 minus square root of 7x. Or, I mean, negative 7 square root of x minus 7 square root of x. Those two are not opposite, so they are not canceling out. So that's going to be equal to negative 14 square root of x. So if I go to the next step, the top part is going to be x minus 14 square root of x plus 49. We do not have any like terms, so it stays as it is. At the bottom, though, we have, let me use another color maybe, this one, why not? We have negative 7 square root of x plus square root. Negative 7 plus 7, they are opposite. When you add them up, it cancels out. So therefore, these two cancels out. And I'm left with x minus 49. You see? No more square roots. That's why you multiply by the conjugate, because the middle terms usually cancels out. Not usually. They always cancel out. That's why you multiply by the conjugate. Okay? And now you have x minus 49. And that's the equivalence. And that's the process of rationalizing the denominator for both of them. All right. So here it wants you to rationalize the numerator versus the denominator. You go through the same process, but instead of focusing on the denominator, you're just focusing on the numerator. And then here you just multiply the top by square root of 6 minus x, at the bottom by square root of 6 minus x as well. And then you simplify. All right. All right, so here I'm not going to do a lot of them. I'm going to let you do these on your own. I'd like to go, because I'm running out of time, I'd like to go into equations, and those are more involved in the process, so I'd like to do these, right? And it takes a long time usually. All right, so let's do solving a radical equation. I'm sorry. All right, so the process of solving a radical equation is to first to isolate the radical expression on one side of the equation, right? So here you can see that we have the square root of 12x minus 12 here, combined with negative minus 2, right? We don't want that. So therefore, we need to move that negative 2 to the right side of it. It's going to become positive 2, right? So the next step, I'm going to have x plus 2 equal to square root of 12x minus 12. Okay? Now it becomes easier to get rid of that radical, because our process is to get rid of the radical, right? So that's our goal. So second, get rid of, square both sides, right? So based on the index is 2 here. So I need to get rid of the radical, I need to raise this to the second power, right? Because it's going to kind of, this is the same thing as 12x minus 12 to the power of 2, and then the index is 2 over 2. And you just get 12x minus 12. That's exactly what we want. Okay? So whatever the index is, if my index is, let's say, cubic root of x minus 1, then I'm going to raise it to the power of 3 to get rid of the radical and just get x minus 1. That's the goal. Okay? Alright, so in this case, I raise to the power of 2, and then I have to do the same thing on the other side. But you gotta be careful here, because a lot of you might be tempted to say, okay, if I have to raise it to the power of 2 on the left side, then I'm gonna do x squared plus 2 squared. Nope. Cannot do that. Okay? What you need to do is to raise x plus 2 to the second power. Right? Very important. You can, whatever is on the left side, the whole thing, put in parentheses and raise it to the power needed. Okay, so we have x plus 2 squared, and then this. So the next line, if I do x plus 2 times x plus 2, I'm just going to break it down like this, is equal to 12x minus 12. Okay? Let me expand this, and it should give me, x squared plus 4x plus 4 equal to 12x minus 12. Alright, so what's happening here is that we're getting some type of quadratic equation, because I have the x squared term and I have an x term, right? I have 2x term and so on. So what I can do is to use my knowledge of quadratic equation to solve this. And what it requires is that I need to move everything to the one side of the equation and make it equal to 0, right? So we're going to use the zero product rule. And so let's do that. So we're going to have x squared plus 4x. And I'm going to move the 12x on the left side and become negative 12x. Plus 4. And I'm going to move the negative 12 to the left side. It becomes positive 12. And then equal to 0. Let me combine like terms. And I have x squared minus 8x plus 16 equal to 0. Alright, so I'm going to factor this. When I factor this, I should get x and x, factors of 16 where the sum is equal to negative 8. Well, negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So negative 4, negative 4. Okay? So, which means that x minus 4 is the same x minus 4. So, x minus 4 is equal to 0 when x equal to 4. Right? So now, we have to kind of pause a little bit. Because we don't know if this is the solution. Right? So, this is the possible solution. So, we don't know yet. Why? Because there are always some restrictions for the square root of an expression, right? Because inside the parentheses, or inside the radical, I'm sorry, you can never have a negative number. So we got to make sure that we don't get a negative number and that one side is equal to the other. So we have to check. So check if x, when x is equal to 4. So here we have x equal to square root of 12x minus 12 and then minus 2, right? So let's see if it's going to pan out. Well, we say that a is equal to 4. So 4 equal to square root of 12 times 4 minus 12 and then on the outside minus 2. So let's see if 4 is going to be equal to 4 here. So it's going to be 4 equal to 12 times 4 is 48. 48 minus 12 is 36. So square root of 36. And then minus 2. And then 4 is equal to 6 minus 2. And 4 is equal to 4. Beautiful. It works out. So now I can say that the solution is 4. Okay? After you check, that's when you can say that the solution is equal to 4. Okay? Let's try to do, I think that's pretty much it. Let's do this one here and see what we get. So here, fortunately, they're both isolated, the radicals. So I can, and they're both with an index of 3. So let's do that. So we have this. I'm going to raise that to the power of 3. I'm going to raise that to the power of 3, right? It should cancel out the radicals. So next I should have x plus 6 equal to 9x minus 4. Easy enough. Then you combine like terms. Let's say I have 6 here plus 4, because the negative 4 becomes positive 4. And then here 9x minus x, because the x gets to be opposite on the other side. Alright, so here I get 10 equal to 8x. And 8x, you divide by 8, and you get x is equal to 5 over 4. So again, you're going to check. So the cubic root of 5 over 4 plus 6 is equal to the cubic root of 9 5/4 minus 4. So let's see. So that's 5 plus 24, 29 over 4. That's the cubic root. And then here we get the cubic root of 45 over 4 minus 16 over 4. Right? And (45 minus 16 is 29. So cubic root of 29 over 4. Both sides are equal to each other. Beautiful. So my solution is 5 over 4. Okay. All right. So I'm going to stop right here. Actually, I am not going to stop right here. Let's do this one here. So let's do this one. All right. So I need to isolate this because you have the plus 9 here. So let's rewrite it as, square root of x squared minus 19 equal to negative 9. All right, so here I have to square both sides, and then I get x squared minus 19 is equal to positive 81. Okay, so you add 19, and you get x squared is equal to 81 plus 19, which is x squared equal to 100. And then you take the square root here. Very important here. If you take the square root of x squared, then, right, it becomes plus and minus 10. It has to represent both the positive and the negative, because here they're not telling you that the variable is positive. So you have two answers for x. So it's going to be x equal to plus minus 10. So x could be equal to 10 or minus 10. So we need to check. And is it possible here? Okay. So I'm going to have check 10, right? So x equal to 10. Actually, it doesn't really matter if it's 10 or negative 10, but you'll see. So square root of 10 squared minus 19 plus 9 must be equal to 0. Okay, let's see if it's going to happen. So that's going to be square root of 100 minus 19, right, plus 9. That's square root of 81 plus 9 equal to 0. And that means that 9 plus 9 equal to 0. And that's not the case. 9 plus 9 is never equal to 0. So positive 10 cannot be my answer. Now let's try negative 10, right? And now you have to be careful, because now if you say, okay, negative 10, right? I'm going to show you the wrong way of doing it. Okay? Even the wrong way doesn't make any sense when I'm going to say it. But the negative 10, so I'm not going to do it the wrong way. So here the negative 10 has to be put in parentheses. Right? Because it means that it's negative 10 times negative 10, which is 100. And I'm going to get the same answer. 9 plus 9. It's not going to be negative 9. It's not going to transform into a negative number. It's not possible. Negative 10 times negative 10 is 100, not negative 100. Okay? So here you got to be careful. And even if you had negative 100, then you will have negative 100 minus 19. It's not going to pan out to be, 0 anyway. So that's that. So it is not positive 10, and it's not negative 19. It's not positive 10, it's not negative 10. Right? So therefore, there is no solution for this problem. Okay? Another way that you could have seen that there was no solution is if you look at the first, if you just look at this here, let me write the x squared minus 19. So I rearrange the radical being equal to some value. Well, we do know that the square root, right, with an even index, that result cannot be positive. Cannot be a negative, I'm sorry. Cannot be negative. Right? This cannot be negative because he has a positive index. It's 2 here. And so, what happened? This radical expression is equal to what? To a negative number. So automatically you can dismiss the reasoning, because you know that there's no value for x squared or for x that when you're going to plug it in, that's going to equate to a negative number, because we just saw that. It's just positive here. Right? So here it's just not going to happen. And you can say from there, this is never going to be equal to negative 9. Okay? Obviously, when we went through the process, it looks like, oh yeah, x is equal to that. But it's because I did square the negative 9. And when you square two negative numbers, it becomes positive. That's how we were able to move on. Okay? So anyway, so we're going to stop right there. And hope this is helpful.